Now let's do some problems. Here's example 1. In the US, the distribution of deaths due to heart disease, 289 deaths per 100,000, standard deviation of 54, and cancer, a mean of 200, standard deviation of 31, are roughly normal. That's very important. Okay, so we know that we could use our normal distribution stuff. In California, 240 deaths are from heart disease and 166 deaths are from cancer per 100,000 residents. Which rate is more extreme compared to the rest of the states, the average for the US? All right, so we have California's death rates from heart disease and its death rates from cancer. And we want to know, okay, which of these are really extreme? One way that we could find out is by finding out the z-scores. All right, so I'm going to get my Excel out. All right, so let's first start with the US. The US mean for heart disease, so I'll use this row for heart disease and this row for cancer. So the US mean is 289 and the standard deviation is 54. For cancer, it's 231. We want to know how extreme the California deaths are. It's hard to compare with just the numbers because even though 240 deaths is less than 289 and 166 deaths is less than, certainly less than 200, we're wondering how much less? How far away from the mean are you? And one way we could do that is by using z-scores, because z-scores will give you the distance in terms of standard deviation. And because these two populations have very different standard deviations, that's worth knowing. And so here's California. Heart disease and cancer. And in California, the mean is 240 and 166. And what we might want to know is the z-score. So what is the z-score? So I might just put standardize and put in my x, put in the mean that I want to, the population mean, the theoretical mean I want to compare it to, and my standard deviation. Now, obviously, I could also do my x, subtract the mean, put that in parentheses, divide by standard deviation. All right, so here we see that the z-score for heart disease is about 1 standard deviation away, negative 0.9. Now, how far down is cancer? How much less is cancer? So how much more healthy are Californians in terms of cancer? And for here, I'll put in my sort of regular formula just so that we practice that too. So cancer, my cancer x minus the population, the theoretical population, divided by standard deviation, because I want it in terms of standard deviation steps. And we find out that cancer, and this is probably because the standard deviation is smaller, it actually is sort of out farther than heart disease. So the cancer rate is more extreme, and more extreme in a positive way. It's more extremely low than heart disease, although they're very close. So here, the trick is find rates in terms of standard deviations, or z-scores. All right, example 2. Heights of male college students in the US are approximately normal. Estimate the percentage of these males that are at least 6 feet tall. Now, it would help if we just sketch this out real briefly. So here's my mean of 70.1 and my standard deviation of 2.7. What percentage of these males are at least 6 feet tall? Now, what helps is if you transform the 6 feet into inches. So that's 72 inches, because these are in inches, because 70 feet is a little crazy. So where is 72 inches? So that might be something like this. What percentage of males that are at least 6 feet tall? So I want all of these people, because all of these people are at least 6 feet tall. They might be 7 feet tall, but they're at least 6 feet tall. So that's what I really want. So what might be helpful is, instead of my raw score, if I could find my z-score, and then I could look it up in the table in the book, or I could use Excel. I'm going to use Excel to help me. Let me move down. All right, so let's find the z-score for this. So in order to find z-score, actually, let me write the formula here. So in order to find my z-score for 72 inches, that would be 72, which is my x, minus the mean, 70.1, all divided by standard deviation, 2.7, because I want the jumps. How many jumps away? My jumps are 2.7. Okay, so that's standard deviation. So now I'll pull out my Excel. All right, and I could just put in 72 minus 70.1, all divided by 2.7. And I find that my z-score is 0.70. And so in order to find the area, the cumulative area, and remember, cumulative area means this side. So Excel is going to give me this side. That's not what I want. I want this side. So I might put in 1 minus this area in order to get that area. So 1 minus. And then I'll just put in my norms, because I have my z-score, inv. And, sorry, I want my probability, so I put in norms dist. Thankfully, Excel gives you a little hint, so if you're off, it's okay. And put in my z-score. And what I get is 0.24. So about 24% of males, of these males, are at least 6 feet tall. So this area is about 24%. So if I want to write it all out, I would write my probability where x is greater than 72 inches is 0.24. Here's example 3. In a standard normal distribution where p of z-score less than 0.41 is equal to 0.659, what is the mean and standard deviation? Actually, this is a trick question. Before you go off and try to find z-score and all this stuff, note that it says standard normal distribution. And in every standard normal distribution, the mean is 0 and standard deviation equals to 1. Ta-da! Example 4. Find the percentage of values in a standard normal distribution that fall between negative 1.46 and positive 1.46. So this would be nice if we sort of sketched it out so that we know what to expect. Here's 0. And since this is a standard normal distribution, that's how I know it's 0. Here's, maybe here's about 1. So here's maybe where 1.46 is, like a little less than half. Mine's probably a little bit too much less than half. Like here. All right. So I want to find this area right in between. Well, usually we look at, the area between -1 and 1, and we know that's 68%. So we know that it's a little more than 68%. It's not quite like maybe 95%. It's not quite that high, but it's somewhere in between 68 and 95%, right? And so let's try to figure this out. One way we could do it is by using our Excel or looking it up in our book. In our book and in Excel, the problem is that they will give you the cumulative distribution. So they will give you this area, right? But what we really want is this area. So what do we do? One thing we might want to do is just use our ability to reason. So this is 50% of that curve. If we take 50% and take away this area, so we could use norms dist and put in -1.46, then that should give us this area right here. So this whole area is this. This area is in blue, and that should give us the red area. Okay? All right. So here, I'm going to put in 50% minus norms dist -1.46. And then I want to take that area and multiply it by 2 because I want the other side too, and it's perfectly symmetrical, so I don't have to do any work. Just have to multiply by 2. And I get 0.8557, right? So a little bit close to like 86%. And that makes sense. It's more than 68%. It's less than 95%, right? So 86%. So my answer is where -1.46, my z falls in between this and this value is is 0.86. All right. So that's example 4, and that's it for the standard normal distribution.